Okay, today we're going to do 4-8, the last section in Chapter 4. It's Isosceles and Equilateral Triangles. So remember to take some notes and complete the Check It Out questions and bring any questions with you next time you come to class.
So we have two learning targets today. I can prove the theorem about isosceles and equilateral triangles, and then once you can prove the theorems, you can apply the properties of isosceles and equilateral triangles.
We're going to start with some vocabulary. So remember, an isosceles triangle has at least two congruent sides. So an equilateral triangle is isosceles as well, because it has at least two congruent sides. The congruent sides of an isosceles triangles are called legs. So here are the two congruent sides, so those would be the legs of that triangle. Vertex angle is the angle that's formed by those two legs. In this case, angle 3 is formed by the two congruent sides, so that's our vertex angle. And then the side opposite the vertex angle is called the base. So this is our base in this triangle. And then base angles are the two angles that have the base as a side. So angle 2 and angle 1 are our base angles. So 3 is the vertex angle, 1 and 2 are the base angles.
Okay, so we have two theorems here for isosceles triangle. Isosceles triangle theorem states that two sides of a triangle are congruent. In this case, segment AB is congruent to segment AC. Then the angles opposite these sides are congruent. So we know angle B is congruent to angle C, or the base angles are congruent. And that's what states down here. Base angles of an isosceles triangles are congruent. You can state that versus the same thing between these two. The converse of that, given a triangle where the two angles of the triangle are congruent, then the opposite sides, these to be opposite, the two base angles must be congruent. So the converse proves the two legs are congruent, and the isosceles triangle theorem proves the two base angles are congruent.
All right, we're going to look at an example using those theorems. So the length of yx is 20 feet, so that's this side. Explain why the length of yz, so yz is going to be this side here, and you can see we have a nice little house here, so this is probably going to be useful. So this is, why would this side be 20 feet, which if you're building a roof, you would want to make sure the two sides are equal. Well, they made it nicely into a triangle, and if you notice, it tells us this angle is, get a pen here, this angle is 40 degrees. It tells us this angle is 140. Well, notice these two angles make a linear pair, so this is going to be 180 minus 140, which is going to be 40 degrees. So now we know these two angles are congruent, and because of that, we know that these two sides have to be congruent, which means this is going to be 20 feet as well.
And now it's your turn. You have distance from Earth to a star in September is 4.2 times 10 to the 13th kilometer. What's the distance from Earth to the star in March? And explain how you come up with your answer.
All right, a couple more examples using those theorems. Find angle F, which is this angle. So what do we know? We know the two sides are congruent, meaning that these two angles have to be congruent. We're going to use that fact and the fact that we know this is 22 degrees to find the solution. All right, so I set out my problem. I know the three angles in a triangle equal 180 degrees. So 22 plus these two angles. So since they're both equal, I just set one equal to x, and then the other one is also going to be x. So 180 is 22 plus 2x. Subtract 22, divide 158 by 2, and I get x is 79. So angle F is going to be 79 degrees. This one, we want to find angle G. Here we see the two sides are congruent. That means our two base angles are congruent, and we're going to use that fact to solve that problem here. All right, so angle G, we see that these sides are congruent, so I use that fact to determine that these two angles are congruent. So I set the two expressions 3x equal to x plus 44, and when I solve for x, I get x is 22. And notice it asked me for angle G, so I have to plug this back in to this expression. 22 plus 44 gives us an angle of 66 degrees.
Nice. And now it's your turn. You have two check it out problems here. one you're having to find the measure of angle H, base angle down here, and the other one you're having to find the base angle here.
All right, two corollaries having to do with equilateral or equal angular triangles. First says if a triangle is equilateral, then it's equiangular. I think we already knew this. We've already talked about it. So here we have a triangle with three congruent sides. That tells us that all the angles are congruent. In fact, we know the angles are going to be 60 degrees. The second one is the converse of that. If a triangle is equiangular, then it's going to be equilateral. So here we have a triangle with all three angles congruent. That tells us that the sides are going to be congruent.
So now let's use those properties of equilateral triangles and find x. Okay, so the first one we had to find x. Find what x is. We know that this is an equilateral triangle. All three sides are congruent, which tells us all three angles are also congruent, and they all must, or each angle must be 60 degrees. So I write the equation 2x plus 32 equals 60. Solving for x, we get x equals 14. For the second equation, or second problem, we have all three angles are congruent. So we have an equiangular triangle, which makes it also equilateral. So our two side measures given must be the same length. Set them equal to each other. Solve for y. We get y equals 18.
Nice.
Thank you.
All right, this is your example. You want to find the value of JL, so you're going to use the information about the congruent angles to solve that problem.
Okay, so to sum this up, we had one theorem, the converse of the theorem, the isosceles triangle theorem, states if base angles, or states if two sides of a triangle are congruent, and the angles opposite the sides are congruent, or the base angles are congruent. The converse states if two angles of a triangle are congruent, and the sides opposite those angles are congruent. And the equilateral triangle, equiangular triangle are corollaries. The triangle is equilateral, it's equiangular, and again we've been stating that, and you guys have known that. Or if equilateral triangles have three sides congruent, then it also has three congruent angles. So, stuff you already know.
All right, so that wraps it up, and we will see you next time.